Here's the snack activity, and here's its solution. Uh, Here's the first step. So I rewrote 9 as 3 squared, and then I rewrote the square root of 3 as 3 to the exponent of 1 over 2, right? And then I continued, and then I think you guys are now familiar with the law I applied. I just multiplied the exponents, which resulted in 2x plus 2. And then I separated the bases in the next step. 3 to the exponent of 2x times 3 to the exponent of 2. And then underneath here, I had 3 to the exponent of 2x times 3 to the exponent of 1 over 2. And then I noticed that 3 to the exponent of 2x is the highest common factor at the top. And then, yeah. And then whatever is remaining, you can put it. So this whole part here, you can just put it into your calculator. Then it'll just give you the square root of 3 in the end, which is what I got there. Are you guys okay? Remember the snack activity, it's not something which I have to write the solution for you. It's just a recap of what you already know. Are you guys okay?
Yes, sir.
Okay, let me go back to you've seen the memo. Here's the memo, right? So can we move on? Learners, can we move on? Are you guys okay with the answer?
Yes. Sir.
Hmm. Remember that
Yes, sir.
the snack activity, I don't have to specifically discuss it with you. You can just ask me questions about it via inbox, but it's not part of the lesson. It's just a, an exercise from the work that I expect you to already know by now. Because I think you can see there that it's just laws of exponents, right? Simplification,
Yes.
right? And I covered that with you. Yeah. So you can just note the answer and you'll just find it in the recording. Can we continue?
Yes, sir.
Okay.
Mm.
So the business of the day is going to be exponential equations part two, because I've already covered a bit of exponential equations with you guys. So I'm moving on to part two of it. And then I'm going to cover third equations as well. So, and that will be done with the first topic of grade 11. So guys, do you allow me to continue?
Yes, sir.
Okay, so the first order of business, we are going to be dealing with simple exponential equations, and of which this is a topic that you must be familiar with from grade 9 and grade 10, right? Simple exponential equations, you're familiar with them from grade 9 and grade 10. So the tip that I always have for simple exponential equations is that you must always find a way to equate the exponents. This is very important, guys. Find a way to equate the exponents, right? So now let me just do example A, right? For example A, I have 2 to the exponent of x equal to 1 over 16, right? So the thing that I have in my mind is that on the left-hand side, I have I have a base of 2 which is attached to the unknown because the x is the exponent, right? So I must find a way to make whatever is on the right to be a what? A base of 2, right? So I must turn this 1 over 16 to a base of 2. So let me continue to explain. And then I know that 16 is just 2 to the exponent of how much? 4, right? And then I have 2 to the exponent of x. And then now I want to take this 2 to the exponent of 4 to the top and this 1 to the bottom. So it's going to be 2 to the exponent of negative 4, right? Right? You remember this law whereby you can just, you know that what it's just equal to a to the x, or the one whereby I have a over b to the exponent of negative c, it's just b over a all to the exponent of positive c. Are you guys okay?
Yes, sir.
So now, once we are here, what can we do now? We have the same base on the left and the same base on the right, so I can just equate the exponents. So I'm going to have x is equal to negative 4. So do you see? Hence, I have the tip, always find a way to equate the exponents. So I made a way. And that way came by expressing this 1 over 16 as a base of 2. Right? Are you guys
Yes,
okay?
sir.
Okay. So I wonder if I have my calculator with me. You guys have your calculators with you?
Yes, sir.
Okay. I forgot mine at home, so I'm just gonna need you guys to do some simple problems. So I have 3 multiplied by 5 to the exponent of x is equal to 0.6, right? So I'm multiplying these two things on the left-hand side. So I have to divide by 3 on both sides so that I can be left with the unknown. So I have 5 to the exponent of what? X. What is 0.6 divided by 3?
1 over 5.
It's what?
1 over 5.
1 over 5, right? And then check now. I must find a way now to equate the exponents, right? But now I have 1 over 5 on the right hand side. So I must express this as a what? A base of 5, right? So now I know that 5 to x, here I have an exponent of 1, right? So this is going to be 5 to exponent of what? Negative 1. Are you guys okay?
Yes, sir.
So x is equal to negative 1 because the bases are the same. I have 5 here and I have 5 there. Are you guys okay?
Yes, sir.
Yes, sir.
Yeah. Okay. So now let's go on to I think now, yeah, let's go on to this problem. Right? So for letter M, what do we have? We have 8 to the exponent of negative x minus 2 times 4 to the exponent of x minus 1 is equal to 0. Right? So now check
Yes,
one
sir.
thing. What am I gonna do? I'm gonna try to I have 8 here, and I know that 8 is equal to 2 to the exponent of what? 3. And I know that 4 is equal to 2 to the exponent of what? 2. Are we okay?
Yes, sir. Yes.
So now what am I going to have? Here I'm going to have 2 to the exponent of 3, all to the exponent of negative x, right? Minus
Yes,
2
sir.
times 2 to the exponent of 2, all to the exponent of x minus 1 is all equal to what? To 0, right? So now I apply that law of multiplying the exponents. What am I going to have? I'm going to have 2 to the exponent of what? Negative 3 what? X minus 2 to the exponent of 1 times 2 to the exponent of what? 2x minus 2 is equal to what? To 0. And then check here. Here I'm multiplying powers of the same base. Check. I have a base of 2. I have a base of 2. So I'm going to add these exponents. So I'm going to continue. I'm going to have 2 to the exponent negative 3x minus 2 to the exponent of what? 2x minus 2 plus 1. All equal to what? To 0. Right? And I'm going to have 2 to the exponent negative 3x minus 2 to the exponent of 2x minus 1. All equal to what? To 0. Right?
Mm-hmm.
So here I have a minus sign, right? So why don't I what? I transpose this value to the right hand side, right? So here, if in case I transpose, that's why I'm gonna have what? 2 to the exponent of negative 3x all equal to what? This negative sign is gonna become what? Positive. It's gonna be 2 to the exponent of what? 2x minus 1. Remember, when I transpose, it does not change the signs of the exponents. It just changes the sign of the what? Of the base, right? So
Yes.
remember the base has a sign of negative 2, but this exponent, it will not change its sign. So it's only the sign of the base that will change, not the sign of the exponent. Are we okay?
Yes, sir.
So this 2, this base of 2 changed from being a negative 2 to a positive 2. Are we okay?
Yes, sir.
Fine. So now I'm moving on to the next step. Now I'm gonna what? Equate the exponents. It's gonna give me what? Negative 3x being equal to 2x minus 1.
Yes, sir.
So now I'm gonna take all the variables to one side. So I'm gonna have what? Negative 3x minus 2x equal to negative 1. And I'm gonna have negative 5x equal to negative 1. Then I divide by negative 5 on both sides. Then I have x equal to positive 1 over 5. Are you guys okay?
Yes,
Yes.
sir. Yes,
Then
sir.
afterwards, we can now check whether is that the correct final answer. So we're gonna take this and then substitute it wherever you see X on the left hand side and check if in case you get. Are you guys okay?
Yes, sir.
Okay. So now let's do the last problem for simple exponential equations. Uh, so now the last one, is this one. It's letter N. Letter N is saying I have 6 to the exponent of x plus 6 to the exponent of x plus 6 to the exponent of x plus 6 to the exponent of x, 1, 2, 3, 4, plus 6 to the exponent of x plus 6 to the exponent of x, all equal to 6 to the exponent of what? 6x. And I'm required to solve for x, right? Check. Is there a law? Remember, so let's say I have a to the exponent of b plus a to the exponent of c. Is there a law for adding powers of the same base? For adding, is there a law?
Mm.
Guys, is there?
No.
Yeah? When I'm adding, is
No,
there a
there is
law?
no law.
There is no law, right?
Yes, sir.
There is no law. So it would be wrong for someone to say, so it would be wrong for someone to say, oh, I'm going to have a base of 6 and then I'm going to add all of these x's. That person would be wrong, right? So what can we say? We are going to say that someone who's going to do this, keep the base of 6 and then add x plus x plus x plus x. That person will be what? Will be wrong. Are we okay?
Yes, sir.
So now let's find the correct way. So now, if in case we are to find the correct way, check. My problem is saying 6 to the exponent of x plus 6 to the exponent of x plus 6 to the exponent of x plus 6 to the exponent of x, 1, 2, 3, 4, plus 6 to the exponent of x plus 6 to the exponent of x, 1, 2, 3, 4, 5, 6, all equal to 6 to the exponent of 6x. Check. How many? So this is the same as that, right? So all of these values that we are adding are the same, right? So I'm adding same values. right? Because all these numbers are identical. Is that okay? You notice that?
Yes, sir.
So now think of it. I want to ask you guys this. If in case I have 2 plus 2 plus 2, what is another way of writing this? It's equal to what? I'm adding how many values of 2? 3, right?
Mm.
So it's okay for me to say this is 3 multiplied by what? By 2. Am I okay to say that?
Yes, sir.
That's okay, right? Even if I have 2 plus 2 plus 2 plus 2. So I'm adding how many 2's? 4 2's. So it's okay for me to say 4 times what? 2. Is that okay?
Yes,
Yes,
sir.
sir.
Okay. So now I'm adding how many 6 to the exponent of x's?
Plus 6.
There are 6, right?
6x.
Is that okay for me to
So,
say that this is equal, it's the same as 6 all into 6 to the exponent of x? Are we okay or are we
Yes,
not
sir.
okay?
Yeah, okay.
yeah,
We're
okay.
okay, sir.
Remember that these are the same values and I have 6 of them. So I'm going to have to say 6 times that value. Even here, I said how many 2's do I have that I'm adding? I have 4. So I'm going to have 4 times that 2. So here I'm going to have 6 times 6 to the exponent of what? X. Are we okay?
Yes,
Yes, sir.
sir.
All equal to 6 to the exponent of what? 6x. Right?
Yes, sir.
Yes, sir.
So now let me just divide this page here and say, okay, I have 6 into 6 to the exponent of x equal to 6 to the exponent of 6x, right? And then I know that this 6 here is all to the exponent of what? Of 1, right? Right? Guys?
Yes, sir.
And
Yes, sir.
here I'm multiplying, right? And then this is a base of 6. This is a base of what? 6. So I'm allowed to add the exponent. So I'm going to have 6 to the exponent of x plus 1, all equal to 6 to the exponent of what? 6x. So now I have the same base. Therefore, I'm allowed to equate the exponent. So I'm going to have x plus 1 equal to 6x. Therefore, now, if in case I take that x to that side, I'm going to have 1 equal to what? To 5x. Therefore, x is equal to what? To 1 over 5. Are we okay?
Yes, sir.
Yeah.
Okay, so yeah, I think that's all for simple exponential equations. And I think I have already taught you simple exponential. Remember, we did some problems related to them earlier on. Not our first time dealing with these kind of problems. I was just giving you a quick revision. Are we guys okay? I think I covered them in video 2 or video 3. Somewhere there. So let me just continue. You guys already know this and you understand. So are there any questions related to simple exponential equations?
No, sir.
No
Yes,
questions.
sir.
So I'm moving on. So now I'm moving on now to the concept of grade 11 exponential equations, right? So these ones are normally called factorization type exponential equations, right? So now with factorization type exponential equations, there's normally a type 1. So here I'm giving you guys scenarios, right? So I have a type 1 scenario whereby I just have to take out the highest common factor. Whereby we just take out that common factor, right? And then type 2, it's whereby we rewrite in quadratic standard form, then use quadratic formula to solve the problem. So quadratic standard form is something of the form of ax squared plus bx plus c, all equal to what? To 0. So this is quadratic standard form. And then this is the quadratic formula. It allows me to solve for the roots. It allows me to find the roots or x values or x-intercepts. Doesn't matter whatever you call them, of a quadratic equation, because this is a quadratic equation. Are you guys okay?
Yes, sir.
So that's just a bit of background. So now I'm going to now be applying this type 1 and type 2. You're going to see me when I apply them. So you can just ask me questions as I'm going forward. Is that okay, guys?
Yes, sir.
Yes, sir.
Okay. So we have a question here. Letter A, number 1, it says, show that 5 times 2 to the exponent of x plus 3 times 2 to the exponent of x plus 1 is equal to 17 times 2 to the exponent of x. So show that is the same as prove that, right? So I'm going to pick a side. So I must prove that this left-hand side is equal to this right-hand side, right? So now I'm gonna pick the left-hand side to simplify because it's the more complicated side. So this more complicated side, I'm gonna have 5 times 2 to the exponent of x plus 3 times 2 to the exponent of x plus 2, right? So let me continue. This first value is okay. I have 5 times 2 to the exponent of x, it's okay, plus 3 times what? I'm gonna separate this value, because that value can just be this 2 to the exponent of x plus 2 can be written as what? 2 to the exponent of x times 2 to the exponent of what? 2. We are okay, right? You know that
Yes, sir.
law. So I'm going to have here 3 times 2 to the exponent of x times 2 to the exponent of what? 2. We are okay with that, guys, right?
Yes, sir.
Guys, remember, as soon as it hits 6:30, please leave. I'm going to end this meeting, right?
Yes, sir.
And then you're going to press on the second link. So for here, we have 5 times 2 to the exponent of x plus 3 times 2 to the exponent of x times 2 to the exponent of 2. I want you guys to notice something. Check. I have 2 to the exponent of x here, and I have it there. And there's all here it's multiplication, and even here it's all multiplication. And then there's a plus sign in between. So therefore, I can take out what? 2 to the exponent of x as a what? As a highest common factor. Are we okay?
Yes, sir.
So let's take it out as common factor. So it's going to have 2 to the exponent of x into 5 plus 3 times 2 to the exponent of what? 2. So I'm going to have 2 to the exponent of x. Put this into the calculator. How much do you get? Put this into your calculator. Please put it into the calculator. How much do you get?
17.
So I have 17.
17.
Right? And then what did they... So this is it's multiplication, right? So it's the same as 17. So it's the same as 17 times 2 to the exponent of what? X. Because remember, the order of multiplication doesn't matter. Are we okay?
Yes, sir.
So now we've proven this, right? We now know that this expression on the left is equal to what is on the right. Are we okay?
Yes, sir.
So now, A1, I had letter A, right? And then I'm going to A2 now, right?
Mhm.
And then now they say hence or therefore, and or like they can say therefore. Like they're now like saying when they say hence, solve this, whatever is underneath. They are saying they are trying to say when they say hence solve now, they are trying to say use what you know from above to now solve the new problem. Check. So I must use what I know from above to solve the new problem, right?
Yes, sir.
But check this equation. Look at what I have here. I have this, right? It's the same as what I had where there, right?
Yes, sir.
And now I'm just solving for x. Here I was not solving for x. Here this problem was just simplification. I'm just showing that whatever is on the left is equal to whatever is on the right. But here, because I have variables on the left and a value on the right, look here it's variables on both sides. So I'm just simplifying. But here I have a variables on this side equal to this value. So here I'm solving for x. Are we okay?
Mm.
Yes,
Yes,
sir.
sir.
And they say I must use what I know from above to solve what is below, right? So the new
Yes.
problem is saying I have a 5. Hey guys, it's almost past, so I'm gonna end this meeting. We are gonna go on to the new link. Are we okay?
Yes, sir.
I'll continue the problem
Yes,
in the
sir.
new link. Uh-huh. Let me stop